Hi everyone. Well, as you know, we're remote today because of the weather, so I decided to change things up a bit. The plan was to talk about CSS today, but as I was looking through my notes, I figured that would be a whole lot easier to do with a whiteboard where I can circle things and point at them and so on. So I'm going to jump ahead a little bit and talk about the implementation of a web server. And we're going to look at some code. And when looking at code, that's an easier thing to do offline so that you can always pause and look at the code more closely than just have it go flying by as I'm talking about it. And that's also why part of today's lecture is pre-recorded so that you can start and stop it. So what you see here on the screen is our sample code GitHub repository, and up here at the top is the URL for this particular folder where I have implemented a very simple HTTP server in Python. And yes, the old Java implementation is here if you want to poke around at that too, but we're going to go through the Python implementation since that's what most of you have more experience with. And I will mention quickly that to make this work, I did implement a class that wraps up the socket in a way that I can read both binary and text. Normally, when you're reading from a stream, it doesn't work real well to read it in text mode and then binary mode and so on. But you really have to do that when doing a web server or a web browser because the headers and stuff are text, but if you're sending like an image, that gets sent in binary. So that particular helper class, this HTTP socket class, is new. I might go back and talk about it a little bit, but the details here aren't highly important. They're more on the networking side of things. All right, so let's go and look at the server. Now this is, I call it a plain text server because some things are hard-coded in there such that it can only send plain text files. All right, so let's look down at the bottom and we're going to start with the main function here. So if you haven't done networking before, when you write a server, you kind of have two different sockets you're dealing with. You have the basic server socket, which sets up the listening. So if I launch a web server or something like that, then that program has to tell the operating system, hey, I'm listening on port 80 or port 443 or whatever the port number is, so that when a connection's made to the port, the data gets routed to that program. So that's what I mean by the server socket. But then as the server is running, you're going to have multiple clients connecting, right? Many different people connect to a web server. And each one of those connections also has a socket, and that socket is where the reading and writing happens. So here we're going to start out with the server socket. And actually, I'll add one thing to the beginning. I'm using Python's built-in argument parser library so that I can grab things from the command line. In particular, I can specify the port number, so I don't have to hard code what port it's listening on. Now, what I did for this is that port is going to default to 8081. And the reason I did that is a lot of standard development servers or little quick and dirty servers like the one built into Python will run on 8000 or 8080 or 3000. And I wanted to pick one that wasn't going to get in the way of other development you might be doing. So I picked 8081 here. But it doesn't matter, right? Anything over 1024 will work. All right. So I'm happy to talk about how arg parser works offline. I'm not going to spend time on it here because it's not really a web development thing, but basically you're specifying what the parameters are. You run the parse args method, and then args here is just a dictionary with the different values somebody might have put at the command line. All right, so we'll start out by assigning port to that default port value. In this case, it's 8081, but then we'll look inside of that argument dictionary, and if I specified a port at the command line, we will use that. And actually, you know what? I just found a slight bug because I've already set up the casting in here, so I can take this out. Sorry about that. So now that we have the port, then what we'll do is we will create that server socket. by running the socket function from the socket library and some configuration here, that AFINet and that sock stream. Again, I'll leave that to 457. It's just setting up some of the details you need to get a socket set up. And then we'll save that socket to a variable called server socket. This line here, we're setting that socket option. I found that on Stack Overflow. What was happening without it is when I would close the program, it wouldn't release the socket right away. So as I was trying this out, I would find a bug, I'd hit Control-C to close the program, and then I couldn't launch it again because the OS was still hanging on to the socket. That seems to have solved that problem. Okay, so we create the socket object. That socket object is set to use TCP and our standard internet addresses. I believe that's what those two parameters mean. And now we need to bind it. So when you call the bind function, that's where the library goes and talks to the operating system to say, hey, I'm listening on whatever port, direct the traffic here. We also need a host parameter, and that host parameter is just set up to be the standard loopback interface. And then we call the listen function, which then prepares everything to actually do its job and sit there and be ready to accept connections from clients. Now, I've been a little bit lazy. I just set this up with an infinite loop. But what's happening here is when we call accept, then in a simple implementation like this, the program just blocks. It waits for a client to connect, right? It waits for that connection to come from outside that says, hey, I want to talk to the program listening on port 8081. And so when that connection comes in, it returns two values. The connection itself, which is another kind of socket, that's what we're going to read and write on, and also the address. And we don't really need the address. I'm just going to print it out. But once we have that connection, we have that object we can use to communicate with the client, then I'm going to hand that off to a function to handle that one session. So think of this function we're calling as a session that's going to have a conversation with a single connection by a single client. It's going to handle I guess I should have said this the first time. It's going to handle a single request. And then when that request is done, the loop comes back up to the top and it will go and accept the next connection. Now notice what's happening here is this is not multi-threaded, so this server can only handle one connection at a time. So if a second connection comes in while the first connection's being served, that second connection will just have to wait. I mean, that's fine for a demo program like this. Obviously, a commercial server would have to be multi-threaded. All right, so let's look at the function, the handle connection function. And do remember that this is a single transaction. This is a client coming in, asking for some data, and that's it. So one client asking for one response. Now, this connection, this object labeled connection, I can read and write from directly, but the details of how to get both text and binary data through that are a little bit messy, so I wrapped it up in a class I wrote called HTTP Socket. I'll circle around and look at that. But for purposes of what we're doing here, just realize that this object has different read and write methods on it where we can pull data out of the socket or send data back to the client. So if you remember how HTTP works, the client speaks first. The very first thing the client does is send that request, that GET and the path and so on. And so we need to read that. We need to begin our interaction with that connection by listening. So the receive text line is nothing magic. It's just what I chose to name that method that's going to pull bytes out of the socket one at a time until it sees a new line. So it's going to read one line of text. And then I printed it out. After that request, remember, comes the headers. So I set up a loop here, and I'm going to grab one line at a time until the headers are done. And remember, the signal for the headers being done is a blank line. So I'm going to read that line. And if that line is empty, if its length is 0, then we break out of the loop and we're done. Otherwise, we'll just print the header. Got a little bit of debugging left over too. Yeah, sorry about that. So once we have the request and the header and the blank line, the client is done speaking, and then it's our turn. We need to figure out if we have what the client wants, and we need to send it. So I'm going to take that request, again, it looks something like this, and I'm going to break it into its 3 pieces. The verb, which in this case is get. We'll see some other verbs later like post or put. The path, which identifies the particular item that the client wants, and then the version of HTTP. Now, for what we're doing here, we're only handling GET requests, and we're not getting into a lot of detail of HTTP, so the only thing we need is this path element, which is in slot 1 in the array. And typically, that path comes in with a leading slash. Actually, the leading slash is going to get in the way, so we need to remove it. So I've got the parts, the 3 pieces of that request. I'm going to take the element 1 of that, which is the path, and then this part here removes the first character. What it's really doing, well, okay, so remember that path is a string, which is more or less a character array. So I want everything starting from index 1 through the end of the string, which is everything but index 0, everything but the first character. So now I have the path. And so here's the model we're working with. In the very first days of the web, the vast majority of web requests were simply the name of a file. So this path, we're going to treat it as if it's the name of a file relative to the current working directory that the server was launched from. And that's why I removed that first character, that initial slash, because then it changes it from an absolute path to a relative path. All right, so now the client has asked for a file, because that's the only model that this simple web server supports. So we need to see if that exists. So we'll just use a built-in library call for Python to say, hey, does this file exist? If it does, and I hope it does, then we're going to take the contents of that file and send them back through the socket to the client. But first, we have to deal with our own response headers. So we're going to send a line of text. Again, this is the method name I chose. This isn't a standard library or anything. And this send text line also adds the required new line and line feed characters at the end, so I don't have to type them out all the time. So there's this response. I'm responding with the version of HTML I support. The response code, in this case, okay, right? I can send you the data and the message that goes with it. And then there are 2 response headers that are standard that should always be there. The first is the content type. So are you sending plain text, HTML, a JPEG, a GIF, a PDF file? Because what you're sending is just a stream of bytes, and the client needs to know how to interpret those bytes. Are they text? Are they HTML? And so on. Now, to keep this simple, the only content type that this supports is plain text. So I've hard-coded text/plain as the content type. You also have to tell it how much data it's sending. Now, some web servers and web browsers can be a little bit resilient and just assume that everything until the socket closes is the content, but really the right way to do it is to say, this is how many bytes. And of course, if we were sending multiple files through one connection, this would be critical. You'd have to know when one document ended and the next one began. And so you see up here, I glossed over that quickly, but the way I know how many bytes of payload, how many bytes of data I'm sending is I am just going to ask the operating system how big is the file. That becomes my file size. And then just like on the client side, when you sent all the headers, you signal that you sent all the headers by sending a blank line, and that's what I've done here. So when the server responds, there's a blank line between the headers and the content, the payload. So now we can send the file. And that's basically just a loop where I read in one line from the file and send it immediately through the socket to the client. And we'll just send it one line at a time. Not necessarily the most efficient way to do that, but again, the focus here is to simplify the code, not necessarily to make it production ready. When that loop is done, we'll exit the with block, which closes the file, so I don't have to do that I don't have to do that explicitly. And then we'll close the socket, and by closing the socket, that is that connection just to the one client, the function ends, and so we come back to this loop here. So we'll come back up to the top of the while loop and wait for another connection. Now notice that this is sequential code, again sticking with the simplicity, so this server can only handle one connection at a time. If a request comes in while the server is handling another request, that second request gets queued and would be delayed. Not a big deal for what we're doing here. Obviously, a real production server would need to be multi-threaded so that it can handle multiple requests at the same time. All right, let's try it out. So I'm going to take a quick look at the directory here. This is where the code is, the server and that helper. And I'm going to run the server right out of here, so that will be our working directory. So we launch it and we see that it just sits there and waits until a browser connects to it. And because HTTP is a standard, we can connect any browser to it, even a real production server like Chrome. So we'll connect to 8081. We'll use HTTP socket as our path. That's the other source code file there. And we visit that web page, and sure enough, there is the contents of that file, just simply displayed as plain text. All right, so let's see what our server did. Come back up to the top here. When the connection comes in, so it says connected by and gives the address. That's what we can see here. The connection came from this very machine. That's why we have that 127.0.0.1 address. And then it gets handed off to this helper function here. And then what do we print? We print the request. So there's the request, the get, the http socket.py, right? There's the path, this part right here. But notice that it does come in with that leading slash. So we want that to appear to be a relative path name, which is why I had this part here take that slash off. We also have the headers. So these are similar to what you would have seen in the homework. We've got the host. Now, Chrome is requesting a keep alive. It's saying, hey, let's send all of the assets down the same TCP connection, but we're keeping the server here. We're keeping the server simple here, so we're not going to do that. Right? We saw these user agents and cookies and all sorts of stuff. And then prints that separator. So there's the separator. And then it opens the file and sends the file and satisfies the request. We can even maybe take a look here. I found a bug. I wonder, always dangerous, but I'm still wondering if this is the problem. If the browser is still expecting the connection to stay open. So since we're not going to do that, what if I tell it explicitly to do a connection close? So let's fire up the server again. This time, let's open the inspector window. Okay, so this time it did handle the request. Okay, and we can see the response. and we can see the headers that I sent. I specifically sent the close and the text plain and the content length. All right, and then it's waiting for the next request. Plain text server. Okay, good. I was able to send 2 requests in a row. All right, and then so we got one more other thing to look at. What if I ask for something that doesn't exist? So maybe I misspell plain text server. I get a 404. Right, so if the file doesn't exist, there we go, right? This is the if statement. If the file doesn't exist, we come down to the else block. I'm going to create the message. Just a real simple message that says, hey, you know, the file whatever is not found, right? File plain text server is not found. Now that is still an HTTP response, so it all has to be formatted the right way. So HTTP 10. This time I'm sending the 404, not the 200. My message is just going to be plain text. I do need a content length. That's why I set the message here in a variable so that I can then send the length. So it's the length of the message and then plus 2 more because this function here is going to add that carriage return in the line feed, blank line, and the message, which is what you see right here. All right, so now let's think about a few things. So this server really only has one thing it can do, and that is find a file relative to the current working directory and send that file as plain text. So what are some other things you might want to do? Well, we might want to handle other file types. So if I put in an HTML file or I put in an image file, what would have to change? So pause the video and think about that for a minute. What would we have to change in order to send other file types? Well, there's 2 main things you'd have to change. The first is you would have to set the content type accordingly. Now, that can be very simple or it can be very complicated. A good first pass at getting the content type set is to just simply look at the extension. So if the file ends with .htm or .html, send it that way. If the file ends with .jpg or .jpeg, then set the content type to image JPEG and so on. So just simply using the extension as a clue is perfectly reasonable. A real web server would try to be a little more robust than that. So for example, they might read the first few bytes of the file to see if there's a magic header. A lot of image formats like JPEG have a particular sequence that's the first 3 or 4 bytes. So even if the file wasn't named right, a web server might be able to take a pretty good guess. An HTML document begins with that doc type HTML and so on. There are also web server specific ways where you can put some metadata in your website saying, hey, this file should have this content type. I don't think we tend to do that very often when we're building websites. We follow the naming conventions, the extension connections, but I think there are ways of overriding that in Apache and things like that. So that's the first thing that would have to be done. The second thing that would have to be done is we'd have to replace this while loop, which is text-based, with a loop that reads data as bytes. That code would go in this helper class, and I don't quite have it ready yet. It's pretty similar to this piece here, the transfer data, although that's for the client, so it transfers the other way. So I'll get that added in the next couple of days, and we will revisit the topic. So I imagine at this point your brain's getting mostly full. We're a little over 20 minutes into a video, which is like 40 or 45 minutes of lecture time, because in videos you don't have interruptions for questions and so on. And in the video, I can take out all of the dead space that would normally happen while I'm up front in the classroom talking off the top of my head. So here's what I want you to do with the rest of the time for this lecture. first, take this code we've been looking at and modify it so it can serve HTML. So that means looking at the file extension and setting the content type correctly. And when you do that, point a real web browser at it and make sure the page actually renders as HTML. So this will be part of that homework 2 that I haven't quite released yet because I'm not quite happy with it. The next thing you'll do for homework 2 is also get that server to handle images. Now, because you'll need that byte transfer to make this work, I'm not suggesting you have to do it today, but it will show up in that homework 2 eventually. So if you're comfortable with that kind of code and you like that challenge, go for it. Otherwise, when you get here, just wait until I have the better instructions ready. And then, after you've gone as far as it makes sense to go with your Python web server, then switch over to the HTML CSS homework. Let me show you that here. So this will be homework 3, where you're going to use HTML and CSS to build and style a static Wordle board. So you're not going to be playing this. It's not going to be interactive. You're just more or less drawing the picture you see on the screen. You can use different words if you want. So we are a little bit ahead on this in terms of what we talked about for CSS, but we've talked about enough of it and we've talked about enough HTML that you could also productively get started on this. Okay, so that should allow you to make good use of this remote hour. And hopefully we'll be back in person on Friday. And then I can finish up both the web server and the CSS parts that we haven't gotten to yet. Now, like I said, on Piazza, my plan is to be available during the entire 10 to 11 o'clock hour. So even though you'll be watching the video asynchronously, I will be treating that 10 to 11 o'clock hour more or less as an office hour, so you can jump on, ask questions about things in the video that I may not have covered as well as you'd like, or just to help out with either of those assignments as you're getting started on them. All right, so that's it for this video. Hopefully I'll see most of you online tomorrow, and stay warm.